This is formed by water vapor erupting from the small icy world Enceladus. Enceladus, like Europa, may well have an ocean buried under its icy surface. In fact, we wonder if such subsurface oceans are common in the cold outer reaches of the solar system. In this case, water erupts from cracks near Enceladus' south pole. Freezes into small, icy particles, and spreads out into a gigantic flat ring surrounding Saturn. Seen from the shadow side of Saturn, with the Sun behind the planet, the ring is illuminated by scattered light, like fine smoke. One small point of light in this picture is not from the Saturn system. It is our own tiny ocean world, 1 billion miles away. This is an immense swirling anticyclonic storm, large enough to swallow the Earth 3 times. The Great Red Spot has been a part of Jupiter's atmosphere for centuries, as long as we've been observing it through telescopes. The entire storm rotates counterclockwise every 6 Earth days. Winds at the periphery of the storm blow at speeds of 300 miles per hour. The striking red colors are produced by sulfur-rich gases. The more vivid shades of red are produced by higher temperatures, deeper in the atmosphere. As far as we know, Jupiter's atmosphere, like the other giant planets of the solar system, extends on into the interior of this world until, without reaching a solid surface, the extreme pressures of the overlying layers of gas compresses it first to a liquid and then a solid. Saturn, too, has a gigantic swirling storm. Strangely enough, this one is at the north pole of the planet. It's a hexagonal pattern of winds rotating in synchronization with the deep interior of the atmosphere, once every 11 hours. Each side of this hexagon is the size of our Earth. Strangely enough, there is not a similar sized storm pattern at Saturn's south pole. Uranus is the smallest of the giant planets. As a result, its atmosphere is cooler and less active than its larger cousins. The atmosphere is tinged blue by a small amount of methane. Uranus rotates on its side as it orbits the Sun, perhaps the result of an ancient collision. Sometimes the poles of Uranus point directly to the Sun, and the banded clouds show a strange bullseye appearance. Neptune, the outermost giant planet, is slightly larger than Uranus. It has a more active atmosphere. That included a giant anticyclonic storm similar to Jupiter's Great Red Spot. This storm, the Great Dark Spot, was smaller though, only big enough to swallow the Earth once. The storms on Neptune seem to have lives much shorter than those on Jupiter. Pictures from the Hubble Space Telescope tell us that the great dark spot has already vanished, to be replaced by a similar storm. In this outermost giant planet, wind speeds are extremely high, 1,300 miles per hour, almost faster than the speed of sound. Fine, wispy clouds of methane ice crystals are swept around the planet by these winds. As we pass beyond Neptune, it forms a giant crescent in our sky. Its companion moon, Triton, lights its night side. Aside from a vast swarm of small icy comets, we are now at the outer edge of our solar system. The Sun here is a tiny point of light, almost 2,000 times dimmer than in the Earth's sky. And now, to move much closer to the Sun. Our neighbor Mars is our sister world. Its surface water long depleted, the desert sands of Mars are scoured by winds. Humans now have explored this cold, arid, dusty world for 50 years. Currently, we have 5 functioning spacecraft orbiting the planet and 2 live rovers on the surface, Opportunity and Curiosity. Curiosity's arrival, shown here, occurred 3 years ago. What have we learned from this detailed study? We know now that Mars was warmer and wetter in the past. Features like these ancient dry river valleys and chaotic canyons record an ancient history, perhaps billions of years ago, when Mars was the home of large amounts of liquid water. There were lakes, rivers, and perhaps even an ocean. Covering what is now an enormous plain in the northern hemisphere, the Vastitas Borealis. Where did the water go? Mars, a world 1/3 the size of the Earth, never had strong gravity to hold on to a thick atmosphere. As the atmospheric gases were lost to space, the water evaporated with it. A small fraction of the remaining water froze at the poles and in permafrost deposits underground. These early bodies of water laid down sedimentary layers. Our rovers have been closely studying these layers at multiple locations. The chemistry of these sedimentary layers reveals a history of highly salty waters that became more and more saline as the water evaporated away. The Curiosity rover was landed in Gale Crater, once the site of a lake. Slowly, it's climbing the central mountain, Mount Sharp. Periodically, it will stop, drill holes in the rocks, and examine the chemistry and crystallography of the minerals. just like a good robotic geologist. The closer it gets to the top of the mountain, the further back in time we go in our examination of the death of Mars's ancient order. In recent news, detailed imagery from the Mars Reconnaissance Orbiter has revealed gullies in Martian craters, possibly carved out by flowing water as we speak. The origin of this water is still a mystery. Was there ever life on Mars? In its warmer and wetter past, some hardy Earth bacteria could have survived in these ancient bodies of saline Martian water, just as they do in Yellowstone Park right now. But did this ever happen? This is the very big question we hope to answer with Curiosity and missions to come that will be even more capable. Sometimes in the evening, Curiosity can look with its digital camera eyes at the setting sun. Just a little smaller than we see on Earth. Sometimes there is a little point of light above that sun. A sharp-eyed individual would make out 2 points of light very close. These points of light are our Earth and its moon. Our ocean world Earth is made more precious by our exploration of the marvelous worlds of our solar system. Water there may be in abundance elsewhere, even in liquid form, as we've seen. But the surging of an ocean, the biological richness of a tide pool, the interplay of life in 1,000 forms, birds, fishes, crustaceans, kelp, algae, all of this, as far as we know at present, belongs to our world alone. We shall not cease from exploration, and the end of all our exploring will be to arrive where we started and know the place for the first time.